Hello and welcome to the last session here at Global Azure Austria, to the last time slot. Some people are still joining us. Super love that. I hope you all have drinks. I hope you all have some coffee or whatever you need to stay awake during the last 45 minutes. And I think now we can get started. Maybe some people will finally join us. I called this session "Let's Write an Agent" because today I would like to show you how we can write an agent. Maybe you have seen some presentations from myself about how to write chatbots. I did that last year also at Global Azure. Last year also I showed something about hosted tools in OpenAI. And since last year, a lot has changed. And today we are going to write a little bit of code and taking a look how we can evolve chatbots and function tools to something which we could call an agent. We are going to use Python today, and we are going to use an open source framework, which is not particularly tied to OpenAI, but I am going to use OpenAI. So I'm connecting to OpenAI, and I'm going to use the models GPT 4.1 and GPT 4.0 mini. Before we write any code, let's quickly discuss what an agent really is. Let's see if you are still awake. If I would ask you, what is an agent? What would you say? What is a typical property of an agent, not just a chatbot? Any ideas? Yeah.
It does something for you. An agent does something for a
Okay.
person.
An agent does, it's not something that you can just talk to or ask it to generate a bedtime story for your little brother or your little sister, but it does something for you. Yeah, absolutely. Anything else? I would add something to your comment. I would say it does it autonomously. I don't need to tell it specifically, hey, do this or that. To make a long story short, I could, for instance, say, I am hungry, and this thing automatically orders a pizza. I don't need to tell it, order a pizza. I just say, I'm hungry. And if this thing knows how to order a pizza, it will do that. And if I give it more option, if it can order a pizza or Asian food, it will probably autonomously decide to ask me whether I want to have Italian food or Asian food, and then order a pizza or maybe some wok dish or whatever you want to have. So that is particularly a very good specification of an agent. We could even say that some agents are even more elaborate. They are called multi-agent systems. So you have specialized agent, and there is, let's say, a kind of triage agent sitting on top, deciding what the user wants. So if the user says, I am hungry, then this triage agent can take the user seamlessly to a specialized agent to order food. But if the user says, I need help with my Python homework, then it directs the user to a specialized agent that can answer questions about Python, for instance. So this is what I call an agent system. It can autonomously choose and use tools, and it can organize work so that it is delegated to specialized agents handling specific tasks. And this is exactly what I would like to work on together with you. Now let me show you what I already have here. I have a Python environment, very, very simple. It's really super basic. As you can see, it consists of a single file. You can see it here, main.py. Is the font large enough? Yeah, are we good? I see thumbs up. Very good. We have a little bit of a static website here. It's just an HTML file with a little bit of JavaScript. Today, we are not taking a look at JavaScript and HTML, so just accept it. It's not very beautiful, but it does its job. It's just a static website. And for the Python people in the room, I'm using pipenv as my dependency management system. I'm using MyPy for static typing, and I think that's essentially it. Let's quickly take a look at the pip file so that you all know which libraries that I'm going to use in this course. I'm going to use Fast API for implementing a web API. Of course, I'm using the OpenAI API. I'm using this framework particularly with OpenAI, but as I said, it's open source. So you can use it with Claude if you want or something else. Yeah, I'm using .env, but that is not important. And finally, I'm using the OpenAI Agents framework. So let me quickly go to my browser window here. This is the framework that I'm using today for this talk, OpenAI Agents SDK. Again, this is open source and it's Python only, at least for the moment. It's Python only and it's Python native. So it's using very specific features of the Python programming language to make it easier to write agents. Maybe in the future, this framework will be made available for other languages. I don't know, but currently it's just Python. And please forgive me if I make Python mistakes. I'm just rediscovering my love for Python. You know, I'm a strictly typed fan. I love TypeScript, not JavaScript. I love C#. I love Rust. And now in Python, we can use static typing. And now I love Python again. So Python is a great language. And today, yeah, let's discover Python. So this is essentially what I do. If you would like to recap what you see here at home, you should use these libraries. Okay, just install them and we are fine. Now, this here is not an agent yet. It is a very simple application which sets up a web server with fast API. Here you see I am mounting a static web server for the static folder here. So whatever is in this folder will be served statically to the client. Put your HTML files, your CSS files, your JavaScript files, your images, whatever, put them into the static folder. And this is just the mounting of this static folder for static website. I think we shouldn't talk about CORS. I don't particularly like CORS. A lot of my white hair on my head are because of CORS. So let's simply close it and not talk about it. Then I have a slash route, which just returns the index.html. And then I have a chat route, which gets a user parameter, user input, and then does something which is the first very important topic when you are building agents. It uses a streaming response to use a protocol which is called SSE, server sent events. If you're not, who does not know about what server sent events is? Just get an idea. Okay, I would say a third of the people here, that is my homework to you. Look up server sent events. It's cool. And it's super, super relevant when you build something with AI today. Because do you know in ChatGPT, this typewriter effect where you see one token after the other, where you can read the minds of the AI? This is server-sent events. So every single token is streamed from the large language model over the web server to your browser or your ChatGPT client. And this is done using the server-sent events protocol. So try to get familiar with it. And luckily, in Fast API, server-sent events is natively supported. By the way, any C# developers in the room? Are you looking for .NET 10? It will be one of the big additions to .NET 10 support for SSE. Well, why do you think? Because of LLMs, obviously. Join us. Join us. Okay, so this is SSE. And please take a look here. This is the amazing output that our agent currently returns. We are simply yielding two SSE messages, data, and then we say, hello world. So let's try this thing, okay? Let's run this thing. We can run it in the debugger, I think. Python debugger, take the current file. And if everything works out nicely, it should start the web server. Web server is running. I open the web browser. Here it is. And then maybe so let's do it like that. Hi. And if I run it, it says hello world. Well, obviously, this is what we created, right? Now, let's add our first agent. Okay, let's stop this guy. Good. Let's program an agent with this agent framework. And the first agent that I would like to work on together with you is a Python tutor. So let's call it a Python tutor. .py. Okay, very good. So first, from the agents framework that I told you about, OpenAI Agents SDK, we import something which is called an agent. That's essentially the base class for our agent. And let's say we are creating a Python tutor equals to agent, and then let's set up this agent here. First, give it the modal. I am going to use the GPT 4.1 model for my agent. Then I'm naming this thing the Python tutor. That is good. I think that should be fine. Then we have a hand-off description. Now, what is a hand-off description? Let me copy the hand-off description from my notes here so you don't need to watch me typing. You have to understand that we are going to build an agent, a multi-agent system. So we are going to have a triage agent, and this triage agent will decide whether the question relates to Python or something completely different. And this description is metadata, which tells our triage agent when to hand off work to this specific agent. Okay, so this is what we do. In real life, this will probably be a longer text, but for us, it's perfect. And then I sat down and wrote a little bit of a prompt. And this prompt is a little bit longer, so I don't want to bore you when I write this thing. As you can see, you are a Python tutor, an expert assistant for students learning code in Python, and so on. And so that we see what's going on, we are going to say, always start your response with Python tutor here, just so that we see which agent is currently answering. And then I wrote a little bit of guidance for our small little agent. You can grab the source code from GitHub if you're interested. I can show a QR code at the end, and you can take a photo and you can take a look at the code later on. This is a very simple tutor just to get started, okay? So I hope we are good. Let's do that. Now, we need to set up the triage agent. And let's do that here. And this triage agent, I will not type this code because I would like to spend more time describing what I do, describing you the concepts and not you watch me typing. Here we are. Now, let's get rid of that one and let's get rid of the guardrails. We will do that in a second, and let's import the Python tutor. Now you see this triage agent is the basis for a multi-agent system. You determine which agent to use based on the user's coding related question. And currently we only have a single tutor, and that is the Python tutor. And you need to understand that here we can add additional agents later on. And with that, we get a multi-agent system. Pretty simple, pretty straightforward, very nice programming model, I think. By the way, there is a super interesting protocol coming up. Have you heard from Google Agent to Agent protocol, this one? If not, I highly encourage you to read up on it. I will not cover it today because I only have 45 minutes, but it's super interesting. Essentially, what Google does is they are standardizing or trying to standardize the cooperation of multiple agents working together. And these agents can be distributed over a large network. So essentially, you will have in the future multiple agents sitting somewhere in your distributed system. And this agent-to-agent protocol is essentially a discovery protocol where we can find these agents and dynamically add new capabilities to our AI company. Some people say the future of IT departments is more HR related, but not biological HR, but AI HR. So this is where all this thing is coming. So as in IT, we are coordinating a fleet of AI agents, and this is what this protocol is all about. In our case, we will not make it so complicated. We just stay inside of one application. But I wanted to set this pointer for you so you have something to read and take away from this course, which goes beyond these, I would say, simple to medium complicated scenarios that you see here. Now we need to find out how to process this input. Now here again, I have a little bit of code prepared, and I will copy this code and delete a little bit of code, and we'll come back to some code later on. I will delete this one because I don't want to talk about that yet, and the rest should be fine. Let me show you what this code is all about, and I would like to draw your attention particularly to these few lines of code. What they essentially do is they are running an agent. Please note that here we are receiving the triage agent. This is the agent that we run. We give this triage agent the user input, and then we run run streamed. Run streamed means that we tell, in this case, OpenAI, that it shouldn't wait and wait and wait until the answer is complete. It should take every single token that the LLM spits out and send this token immediately from the LLM over the web server through our code to the browser. So essentially what we have three layers. We have the browser here, we have our API here, we have the LLM here, and we are streaming the tokens. And this code that you see up here is forwarding the streamed tokens to the client. So we get this nice little typewriter effect in our browser client. Okay, are we good? Good. So this is why I'm using stream events. Because I only have 45 minutes, we are not implementing a multi-turn conversation here. So this is a single turn conversation. We can ask a question and we will get an answer. We would have to write a little bit more code in order to make it a multi-turn question, answer, follow-up question, follow-up answer, follow-up question, follow-up answer. We only have 45 minutes and we have so much to take a look at. Then we convert everything into JSON and we send it back to the client. And if an exception happens, we are going to send the error to the client. And to mark the end of the conversation, we simply say end. So the client can stop waiting on further SSE messages. If you know the SSE protocol, then you probably know that the SSE protocol, we do a retry until the client, I choose my words carefully here, until the client says stop. So as the server, you cannot say stop. The client has to say stop. So therefore, the server has to signal to the client, I'm done. Then the client can say stop, then everything is fine. If the server would simply terminate the connection, the client would say, oh, I lost contact to the server. I need to retry, and we are caught in an endless loop. Okay, this is just SSE stuff. So yeah, read it up if you would like to know more. Okay, let's give it a try. Okay, that's right. So far, not difficult, right? Yeah, pretty straightforward. Hopefully it will work. Let's see if it works. Okay, let's run this thing. And let's say a mystery for many, including me, is how do Python list comprehensions work? Let's see. Let's see if we get something. Oh, yeah. Python list comprehensions, blah, 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 blah. Looks very good. Yeah, we get something back. So our agent already works. Very good. I can even show you that this is not a fluke. So I can set a breakpoint here and maybe reload it. For loops in Python. How? And see, we had a breakpoint. So I'm not simulating something. This is really live code. So we saw it works fine. Let's remove this breakpoint. Let's run it again. And it should say, everything's fine. Good. Looks very nice. What it doesn't do, and I particularly don't like that. Let me quickly look that up. It ignored this one. Didn't tell you that. Always, come on, I'm going to shout at the system. Let's see if that changes anything. Okay, let's run it again. Sometimes AIs need a little bit of extra encouragement. Oh, I did a mistake. Sorry. Fine. Run this one. Let's see if it doesn't work. It worked when I tried it before I came here on stage, but we'll see. I mean, it's AI. Python if statement. How? It ignores my comment. I don't know why. It's fine. It's fine. It's fine. Good. Stop it. We are good. So that was the first step. So you see, it's really not difficult. But to be honest, you might say, hey, Rainer, that's not an agent. That doesn't do something for me. Markus, you said an agent does something for me. It can order pizza or whatever. So let's teach this thing a little bit more tricks, okay? For that, we are going to implement another agent. We are going to implement a README generator agent. And this will be the basis for, this could be the basis for a coding agent. Let's found a coding agent. Have you heard? Windsurf was recently acquired by OpenAI for $3 billion. A coding agent. Cursor is valued at $9 billion. So I think we should get our share and implement our own coding agent, right? Let's do that. Let's do that together. Good. Let's add some imports. That's an easy one. And let's add our basic agent here. There will be a mistake in the code here, and we will fix it in a second. So please ignore this thing here. This will be a README generator. Essentially, the prompt that I wrote here tells the system that it should write a README file for a coding project. Similar to what you can do with Cursor here, I could, for instance, close this one and say, write a README file for me. Do not create the file, just show me the markdown. This is what I can do with Cursor, Windsurf, GitHub Copilot, whatever you want. This is what we do, and this is what we are going to build. The important thing, okay, it was not very smart. For this project, of course, not a general README. See what's going to happen? Do you see that one? This is now an agent. This is what you meant, I think. It autonomously decided to take a look at my file system. It autonomously decided to read certain files. It autonomously decided to inspect our entire application, and then it can generate some code. And we want to give this capability of doing things automatically to our agent. This is what we want to do, okay? So let's go to the README generator. This is just the README stuff, but here is the magic. Who has never heard of hosted tools when it comes to AI? Okay, pretty many. Okay, let me quickly show you what this thing is all about so you understand that. Let me go to platform OpenAI. Let's go to the playground. Here you have GPT-4.1, and here I can add tools, as you can see. For instance, I can add a tool which is called Get Weather, and this gets a location, and that's essentially an external tool. We have heard about that in previous sessions. I think in the session of Peter Paul, we have seen something similar, a little bit at least. That is a hosted tool, and you are a tourism agent, and I can say, I want to visit one of Austria's capitals, regional capitals, where the weather is nicest tomorrow. The problem is that OpenAI has no idea what the weather will be in Salzburg, in Vienna, in Klagenfurt, in Linz tomorrow. So it needs to use an external tool, and this is what hosted tools is all about. I run this thing, and then OpenAI will not return an answer, but it will respond with tool calls. See, it autonomously decided to call Get Weather for Vienna, for Graz, for Linz, for Salzburg, and so on. And as the host, this is why it's called hosted tools, as the API or the app sitting around this thing, I can grab these tool calls and say, oh, you don't have an answer for me, but you would like to call a certain functions? I can do that for you. It will not do a REST call. It will not do some database access for you. It will, the LLM will simply tell you, please, dear host, on my behalf, call this function. And the function is just text. And in your code, you will have a big switch statement. If get weather, do that. If get GPS coordinate, do something else. Understood? At least approximately. And the system, the LLM, can autonomously decide which tools to use in a loop, in parallel, in sequential order, whatever you want to do. And then we can answer anything. Okay? And this is what we need to program. Now, if you go down very deep and you take a look at the original API, for instance, this API here, then if you take a look at function calling, you will see that handling such function tools directly with the API of OpenAI is not a trivial thing. But luckily, this Agent SDK makes it super simple to provide tools. Now, some of you might say, well, what can these tools do? Whatever you imagine. It's your code. Do you want to change the temperature in your living room? You can, if you can write code for that. Do you want to order a pizza? You can, if you want to write code for it. Do you want to add security so that the system will not turn up the temperature in your living room to 70 degrees or something like this? You can, it's your code, write whatever you want. The LLM only gets the name and the description of the function. You have to know what to do with the function call, okay? So execute arbitrary code, that's the idea. And now what I did for my presentation here is I have implemented 2 function tools, which we will add here, and be prepared for an amazing developer experience. A function tool in this API, in this SDK here, is nothing else than an arbitrary Python function. The only thing that you have to do in your Python function, first, you have to add this @function tool at the very beginning. This marks the Python method as a tool. And the second thing that you have to do, of course, we all do that. Nobody forgets about that. You have to document your methods appropriately. Everybody loves to write documentation, right? You know, I have some students of mine here in the audience, and for the others, let me tell you, I teach at the HTL Leonding around the corner here, and my students always write great documentation, and they always use great No, I'm kidding. Of course, sometimes they are stressed out and they are not going to do it, but the important thing here is your documentation becomes part of the code, because the LLM only works if you write good documentation. If you screw up with the documentation, the LLM will not know what to do with the tool. So write good documentation, choose good function names, choose good variable names, parameter names, and mark the Python function with this thing here. And then you can do whatever you want here. Do you want to call an existing web API? Feel free. Do you want to access a database? Why not? Do you want to access a drone hovering over your house or whatever? If you can write the code, the LLM can address it. Yeah, Benjamin, you have a question. The agent knows what the function name is. It takes a look at the Python function name, and it really parses the documentation string here. So if you take a look at the second function tool here, you have this args thingy here. So it really uses another Python package to parse the documentation, and from that it extracts the information about the input parameter, function names, the descriptions, and so on. So yes, it knows about the function name. Yeah. And you see, in this case, I added 2 functions. The first one is called list files, and the second one is called read file. See? Amazing. Now we have a second agent, and it's called the README generator. So let's go back to our main.py and go here and give our triage agent additional capability by simply telling the system, hey, triage agent, I have additional capabilities for you. Here is another specialized agent. So now we have an agent for answering Python, and we have a second agent for generating README files that is capable of handling tools. I allow this agent to list files in my folder. I allow this agent to read files on my disk. Okay, so let's see if it works. So we already know that it can answer Python-related questions. That is fine, but we don't know whether it can generate some README file. So let's give it a try. Okay, generate a README file for this project. Now, the problem is OpenAI has no idea what this means. What is this project? It needs to take a look in my folder. It needs to list files on my disk. But of course, I'm not publishing my folder, my files, somewhere on the public internet. No, I'm using the function tools. And the LLM will just tell me, hey, host, please take a look at the files. And then I will return the content of the current folder. So if this demo works, we should get a README file for our application that we are implementing here together. Let's see. Sure, I can help you with that. Ah, very good. It didn't work. Amazing. Good. Not good. So let's see what I screwed up. So I have the triage agent here, and I added the README generator. Let me check. Let me check. Here is the README generator. Looks good. Here is the README generator. And everything looks fine so far. Yeah, I think I'm good. So let's try again, okay? Python source main. Yeah.
You import README generator, but you do not refer to the README generator for README generator. So you're referencing the module, not the object.
Sure.
Yeah.
I think that's correct. But I have notes. No, this is correct. This is correct like that, I think. Nah, I know what I screwed up. I know what I screwed up. I know, you are absolutely right.
From.
Exactly, from Python tutor. This is what, thank you for helping me out. Mario, thank you very much. Thank you for watching me. Sometimes you know that you're sitting here on stage and you're screwing things up. So let's try the Python example again, okay? List comprehensions in Python. Let's see. Python tutor here. Yeah, very good. Thank you very much. Round of applause for Mario. We're catching that one. Thank you very much. And the second one is write a README file for this project and give me a README file. Come on, give me a README file, please. Give me a README file. Main.py doesn't give me a README file. Write a README file for that. I can easily set a breakpoint here and see whether this works. This is something that I wanted to demonstrate after all. So I think I have 10 minutes left, right? Yeah, awesome. We are perfectly in time. Everything is awesome. So let's run the debugger again. Maybe I didn't stop the debugger. It might be that I didn't stop the debugger. Let's see if I imported it now correctly. README generator, yeah, looks good. So let's run it again. Now the browser, now the web server runs. Write a README project, a README file for this project. And here we are. This is exactly what I wanted to show you. It autonomously called the list files function. See, it's using the tool. It's asking my computer to provide a list of files. And you see here, I have all my files in this folder. And if we are lucky, the system will now read particular files. See, it first reads the main.py file. Next, it reads the README generator py file. Next, it reads the Python tutor file. Next, it reads the pip file. Next, it reads the pip log file, the index.html file. It ignored the .env file and all the rubbish in the object folder. And here we are, AI tutor chat. So you see, we now have a triage agent which knows whether to hand over to the Python tutor or to hand over to the README generator. And the README generator has capabilities to use tools to access my local disk. And use your imagination. You can do whatever you want here. Yeah, we have a question, please.
The content of the files counts towards the context, right?
Yes, of course. Very good question. What counts to the context? What do you have to pay in terms of tokens? You have to pay the function descriptions, the documentation. You have to pay for the function calls, the arguments. You have to pay for the results of the function calls. And if it's a multi-turn conversation, you have to pay for all this stuff multiple times. Yes?
Can someone limit it to maybe only sample 3 files so that you limit this in some extent?
Yes, you can limit that to, let's say, 3 files, or maybe only read the first 200 lines or something like this. But you have to write code for that. This is not done automatically.
Write code or write the description of the function?
Both. Both. For instance, if you say only read 5 files, then that would be part of the prompt or the documentation. But if you, for instance, have a database query, then you might need to inject a top clause so you do not get back thousands of records from your database. So the answer is both. Answer to your question? Good. Last step. We only have a few minutes left, and I would like to demonstrate one last thing. And that last thing, I will simply copy it from my preparation. Where is it? Exactly. Here it is. I have my guardrails agent, because the guardrails agent is an interesting one, because this guardrail agent checks whether the user is asking coding related questions. So we only allow coding related questions. Why is guardrailing something that is particularly included? We do not want to add guardrails to every single agent. So our triage agent already has the capability to set up guardrails. So the user can only ask certain questions. And this guardrail agent is really just another agent, but please note that one. You see that? It's using a fast, small, and inexpensive model. So our guardrails use a small language model to quickly determine whether the question is out of the guidelines or inside the guardrails. Understood? So we only have to tell in the main functionality, we only have to tell our triage agent that we want to have additional guardrails. Here you see it, and this time I don't make the mistake again. So yeah, this time it didn't screw up, as you can see. So if I run that again, and now let's try something, and let's say we are a student and we need to write an essay about the history of Austria. Write an essay about the history of Austria. I forgot something. I need to add exception handling. Otherwise, it doesn't work. Here, we need to handle the guardrail exceptions. You see, I'm handling exceptions, and I'm simply returning to the user, this is a guardrail. Guardrail was triggered, okay? In your application, this would probably be more elaborate, the error handling, but I think you got the idea. So let's see. Write an essay about the history of Austria. And here we are. What you also see is that the API automatically, to not waste the user's time, it starts the other agent, but in parallel asks the guardrail LLM whether this is okay. And if it detects that it is not okay, it will stop the original agent and say, stop working. This is not what I want to answer. So it stopped it. And in the middle of the call, it immediately said, nope, we are not going to answer this question. Yeah. And I mean, you can add as many guardrails as you want. You can add guardrails specifically to one agent. You can add guardrails to the triage agent, whatever you need, wherever you need it. Okay? Very nice, very nice. So you see, it's not hard to write an agent. It's not hard to add function tools. It's not hard to write a multi-agent system. But at the end of the day, this is really low code or deep code. It's not like low code, as we have heard in one of the first sessions at Peter Paul, for instance. Now, what else can this thing do? This OpenAI Agent SDK can obviously do a lot more. And I want to spend my last 5 minutes to talk about this thing here, the Modal Context Protocol. If you're not familiar with the Modal Context Protocol, I highly encourage you to take a look at it. It's amazing. It's really amazing. You can do amazing things with it. Why is that important? Now, if you take a look at the repeat generator, there's one here. This function tool. It's nice that we have it here in our multi-agent system, but wouldn't it be amazing if we spend a lot of time writing such a function tool to have this function tool available in Claude Desktop, or maybe in Microsoft Copilot, or maybe inside of Cursor, or maybe inside of Windsurf. I don't want to write these function tools over and over again for every single UI. I want to write it one time and simply plug it into Claude, plug it into OpenAI, plug it into Cursor, plug it into Windsurf, or plug it into my agent system here. And the good news is this is possible with the Modal Context Protocol. The Modal Context Protocol is a standardized protocol for writing collections of tools, tool sets. And nearly every client that you can find out in the wild today supports the Modal Context Protocol. And if you take a look at the sample here, you will see that here it is. It's super, super simple to add a Modal Context Protocol server. As you can see it here, MCP server std.io means run an MCP server and add it to my multi-agent system. The advantage again is that I do not write this code for the tool inside of my application, but I make it available for every client out there. And you know, more and more applications nowadays know AI. So maybe this tool will then be available in Excel or in PowerPoint or in Word or in Slack or in Teams or wherever you want. I wanted to show you a prototype that my colleague Melanie, you have maybe heard her talk, has written, but I didn't have the time, unfortunately, to add it in my to this example, but I would like to show you this example here. For instance, our own software is called Time Cockpit, and I can ask here Cursor to say what projects can I book my work on in Time Cockpit. This one. This is a development environment, and suddenly this development environment is capable of accessing a system, a software as a service system that we write in our application. I can simply say run tool, and suddenly a development environment can talk to our own software. This is possible because we have a Modal Context Protocol server for Time Cockpit, so I can directly access it here. And with a few lines of code, and I'm super sorry that I didn't find the time to embed it in my sample, you could add exactly that MCP into that example to have it in all your agent of it. And that is what I wanted to show you. What is the takeaway that I would like to take away from this course or from this session? There are new capabilities. The new models are super smart when it comes to tool use. There are new frameworks like the OpenAI Agent framework, which make it super simple to add tools. And there are new standards like the agent-to-agent protocol and the Modal Context Protocol, which make it possible to build reusable tools and reusable agents, which will make up parts of the workforce in our future AI-enabled enterprises. I hope you enjoyed this talk. I hope you enjoyed the Global Azure Austria this year. Thank you very much for coming. And if you have maybe 2 or 3 questions, I can answer it immediately. Otherwise, simply come to the front and I'm more than happy to answer your questions. Here we have one question. Yeah.
Yeah, so what's the difference between the A2A and the MCP? It sounds quite similar.
Very good question. What is the difference between A2A and MCP? MCP is a collection of tools, while agent to agent is one step above. It's a handover and discovery protocol for entire agents. So one thing is a tool bag where you have 5 tools in it, and the other thing is really on a HR level. I have 3 Handwerker, craftsmen. Yeah, I have 3 craftsmen, and I need to coordinate work between them. They might internally have MCP servers for their tools, but it's on a higher abstraction level because it's an entire agent. Does that answer your question?
For example, the project you have, you could also have an agent who delivers the project, for example.
Yeah, I could, but the open source framework that I'm using here is not yet enabled for agent-to-agent protocol. Agent-to-agent protocol is very new. It only came out a few weeks ago, so I assume it will come here, but currently it is not capable to speaking this protocol. But Microsoft already said it will work with agent-to-agent. This is a protocol from Google, and you can probably expect that the others will follow. Last question, I think I had one. Yeah, Benjamin, please. Yeah, guardrails. I didn't understand it from an.
In the main type,
Yeah.
The guardrails send an end stamp, like in the braces.
Yes.
But does the other agent still generate the
No.
response?
No, this is the question is if the guardrail is triggered, whether the original call is automatically cancelled. Yes, this is handled by the framework. And that's the beauty of this framework, because it handles such housekeeping automatically. If you are one level down and you're working directly with APIs like OpenAI or Claude, you have to do this housekeeping on your own. So these frameworks, which sit one abstraction layer level above, they are really useful because you have to write less code. Very good question. Thank you very much. Okay, so if you have additional questions, please come to me. Thank you very much for coming. Thank you very much for visiting the Global Azure. Have a beautiful rest of the Saturday afternoon. Oh,